The first report said 7.3, then quickly jumped to 8.0. The US Geological Survey later revised it to 7.5, still massive. For context, anything above 7 is considered major. Above 8? That's great. And since 1900, there have been only about 20 earthquakes worldwide that reached magnitude 8.0 or higher. So this wasn't just another blip on the seismograph, this was a once-in-a-generation event. And it happened in a place where the Earth isn't supposed to move like that. The thing about Drake's Passage is that it's not just an empty patch of ocean. It's the only deep water connection between the Pacific and the Atlantic Oceans. It's like the Earth's plumbing system. Currents and storms here ripple out across the globe. And when the Earth shakes in a place like this, it can do more than just rattle a few seismographs. It can displace water. And when you displace water that violently, you risk a tsunami. Now, thankfully, in this case, no tsunami warning was issued. But here's the thing about tsunamis. You don't need a huge quake to trigger one. The 2004 Indian Ocean tsunami, the one that killed over 227,000 people, was triggered by a 9.1 quake off Sumatra. The 2011 Japan tsunami that caused the Fukushima disaster, that was a 9.0. A quake in the 7.5 to 8.0 range absolutely has the potential to displace enough water to cause catastrophic flooding. And if a tsunami started in Drake's Passage, it wouldn't just hit one country. It could ripple into both the Atlantic and Pacific. It could slam into the southern coasts of Chile and Argentina, wrap around Antarctica, and send waves into Africa and Australia. That's why seismologists were immediately glued to their screens when this quake struck. But let's zoom out here. Why is this quake so alarming? It's not just the magnitude, it's the location. Drake's Passage is mostly oceanic crust, the thick, dense rock that makes up the sea floor. You don't usually see massive quakes there because there's no major subduction zone directly under it. So when a quake this big happens in an unusual spot, it raises a big, uncomfortable question. What's going on beneath our feet? The Earth's crust is like a jigsaw puzzle made up of about 15 major tectonic plates. They grind, collide, and slip past each other. Most of the time it's slow, just centimeters per year, but sometimes the pressure builds, and when it releases, you get an earthquake. Normally, scientists can map out where the danger zones are, but every now and then the Earth surprises us. In 2004, hardly anyone expected a 9.1 quake in Sumatra. In 2011, Japan's coast was prepared, but not for a tsunami that would breach 40-foot seawalls. And in 1960, Chile was hit by the largest quake ever recorded. A 9.5 monster that literally shortened the length of Earth's day by 1.6 microseconds. This Drake's Passage quake is one of those surprises. It doesn't fit the pattern, and that makes it dangerous. There's also something else. Big earthquakes tend to cluster. We go years, sometimes decades without one. Then suddenly we get several in quick succession. From 2005 to 2011, the world saw 6 quakes above magnitude 8.0. Then came a lull, but in the past 2 years, we've already seen an 8.8 in Russia, and now this 7.5 to 8.0 in Drake's Passage. Seismologists call this global stress transfer. When one part of the Earth's crust adjusts, it can shift the stress to other areas, setting them up for their own big release. Which raises the scariest question of all. Is this quake a warning shot? Let's put some numbers on this. Magnitude 8.0 earthquakes release about 32 times more energy than a 7.0. The Chile quake in 2010 released energy equivalent to 500 megatons of TNT. That's more than 30,000 Hiroshima bombs. And while Drake's Passage isn't heavily populated, South America's southern tip is. Cities like Punta Arenas, Chile, population 130,000, and Ushuaia, Argentina, population 75,000, are within range. If this quake had struck closer to land, we'd be talking about collapsed buildings, broken infrastructure, and potentially thousands of casualties. Instead, it happened under the ocean. Out of sight, but not out of mind. And here's where things get even stranger. Seismologists pulled up historical data for this region going back more than 1,000 years. There's hardly any record of quakes above magnitude 7.0 in this exact spot. Yes, Chile's coast is one of the most seismically active places on Earth. But this far south, in the Drake's Passage itself, almost nothing. So when you suddenly see an 8.0 level quake in a quiet zone, it's like finding a crack in a dam that was supposed to be solid. It doesn't just make you question the quake, it makes you question the entire system. So what does this mean? First, it means we're underestimating the risk zones. The Earth is far more interconnected than we like to think. Stress in one region doesn't stay put, it migrates. Second, it means South America could be in for more big quakes. The South Sandwich Trench and the Chilean coast are prime candidates. Remember, the 1960 Valdivia quake 9.5 happened not that far north of here. Third, it means tsunami preparedness matters even in remote regions. The Indian Ocean in 2004 wasn't thought of as a tsunami hotspot. Neither was Japan's northeast coast until it was. But there's also a deeper lesson here. Earthquakes like this remind us that we're not in control. We build our cities, our ports, our shipping lanes, all assuming the ground beneath us is stable. And then in a matter of seconds, the Earth reminds us who's really in charge. The scary part is how little warning we get. Unlike hurricanes or volcanoes, earthquakes don't give you days to prepare. Sometimes they don't even give you seconds. In the case of this Drake's Passage quake, the first alert many people got was the quake itself. Scientists will spend years analyzing this event. They'll debate whether it was a fluke or a sign of larger shifts. They'll refine their models, update their hazard maps, and argue about stress transfer. But for the rest of us, the takeaway is simpler. We are living on a restless planet, and every so often it shows us just how restless it can be. Think about this. There are more than 3 billion people living in earthquake-prone zones. And yet, funding for earthquake preparedness is a fraction of what we spend on things like climate resilience or even space exploration. Meanwhile, a single quake can wipe out decades of progress in minutes. Haiti, 2010. A 7.0 quake killed over 220,000 people. Nepal, 2015, a 7.8 quake killed 9,000 and injured 22,000, and that was with magnitudes below 8. The difference between a 7.5 and an 8.0 is not just a decimal point. It's the difference between devastation and annihilation. So when you hear about an 8.0 in Drake's Passage, don't shrug it off because it happened far away, in a place few people live. But the danger isn't limited to South America. If a future quake in Drake's Passage triggered a tsunami, the impact would ripple far beyond local coastlines. Global shipping around Cape Horn could grind to a halt, choking off one of the world's critical maritime routes. Antarctic research stations could be isolated or destroyed, and the fisheries of the Southern Ocean, vital for food security worldwide, could collapse in a single day. One violent release of energy in the wrong place can ripple through the global economy just as easily as it ripples through the ocean. And here's the thing, Drake's Passage may seem remote, but in a world connected by trade, travel, and climate systems, nowhere is truly isolated. A quake here doesn't just threaten Chilean ports or Argentine cities, it threatens shipping insurance markets in London. It threatens fish prices in Southeast Asia. It threatens climate models that depend on Antarctic current data. In the 21st century, a disaster at the edge of the map can circle the globe in hours. Scientists are beginning to ask whether these quiet zones could actually be the next frontier of seismic risk. The Mediterranean, Cascadia in the Pacific Northwest, the Himalayas, regions that haven't seen their big one in centuries. All it takes is one blind spot in our hazard maps and millions of lives could be hanging in the balance. And the unnerving part? We may not be ready. Funding for earthquake research is a fraction of what we spend on climate adaptation or even space exploration. We can model the path of a hurricane days in advance. We can predict when a volcano is likely to erupt. But earthquakes, at best, we get seconds of warning. This is why preparedness matters, even in places that think they're safe. Drills, building codes, evacuation routes, these are not luxuries. They are the difference between a disaster you survive and one that rewrites history. The Indian Ocean in 2004 wasn't seen as a tsunami hotspot. Neither was Japan's northeast coast until both were hit. And now Drake's Passage has joined that list of impossible places